Our reading this morning is taken from the Statement of Conscience of Climate Change passed by the UUA General Assembly in 2006. Earth is our home. We are part of this world and its destiny is our own. Life on this planet will be gravely affected unless we embrace new practices, ethics, and values to guide our lives on a warming planet. As UUs, how can our faith inform our actions to remedy and mitigate global warming and climate change? We declare by this statement of conscience that we will not acquiesce to the ongoing degradation and destruction of life that human actions are leaving to our children and grandchildren. We as Unitarian Universalists are called to join with others to halt practices that fuel global warming and climate change, to instigate sustainable alternatives, and to mitigate the impending effects of global warming and climate change with just and ethical responses. As a people of faith, we commit to a renewed reverence for life and respect for the interdependent web of all existence. Okay. All right, I wanted to talk about climate change and beyond the science and so forth. Climate change started us thinking and talking about the ethical and moral implications of climate change. As an overview, the Earth is over 4.5 billion years old, and it's had significant climate change throughout its history. The natural causes of this climate change naturally through that period primarily were caused by these things that I've listed here. The variation in what the sun's output is has caused some of that climate change over time. Orbital variation in the Earth's orbit has also influenced that. And then volcanoes put a tremendous amount of carbon dioxide and other gases into the atmosphere, so the variability and the amount of activity we've had with volcanoes across the planet have also contributed. And then more extreme things like asteroid impacts have done things like wiped out the dinosaurs and had other drastic climate impacts from time to time. So those are the natural things. But now we get to the human causes of climate change, which primarily include greenhouse gases, carbon dioxide, which I'm sure you've heard about, as well as methane and nitrogen oxides and water vapor and so forth. And also the things we've done to the surface, cutting down forests. So the deforestation and other land surface changes, urbanization and things like that, and changing the albedo, which is the reflectiveness of the surface, basically soot from our smokestack emissions. When those fall on ice and snow, then those surfaces are not as reflective and absorb that heat. So those are the types of things that humans have caused. Okay, well, looking back over time, this graph shows basically what sea level fluctuation has done over the last 500 million years. So this is a pretty big picture in time. So this is the current way over here to the right. And this pattern here is basically what sea level has done during that period. And that range is hundreds and hundreds of feet. That's how much sea level has fluctuated due to the natural causes of climate change during that 500 million years. So now let's look a little more recently, and we can do that through ice cores that we've collected in Greenland and Antarctica. The drilling down through the ice, we can capture the ice, and in Greenland we can go back 130,000 years, and in Antarctica we can go back 800,000 years. And when that snow fell, it captured what was in the atmosphere, then turned to ice. And so when we analyze the ice now, we can see exactly what the atmosphere was all the way back 800,000 years. So long before, obviously, present times, and realize that humans only go back a couple of 100,000 years. So this is way before humans were even on the planet. So anyway, like I say, we can reconstruct what the atmosphere was like during that entire period. And this is what it looks like in terms of carbon dioxide. So here's the concentration of carbon dioxide on the axis here on the left, and this is basically the present time right here, going back 800,000 years. So what you can see is carbon dioxide has fluctuated a good bit during 800,000 years, but the low is probably on the order of about 175 or so parts per million. That's the lowest. And the highest was probably right around 300 parts per million. And now look what happens on this end of the graph. Basically, this is when our Industrial Revolution started, and now we're actually even above this chart. We're up at about 407. So we're significantly higher than on the planet in 800,000 years. All right, let's look at a little smaller window in time, 24,000 years. This is basically from when the last glaciation occurred on the planet, about 22,000 years or something about like that, and then it started warming up. Notice that this last, around 6,000 years, 6 to 8,000 years has been relatively stable. And that has given rise to agriculture and urbanization and development of various cultures across the planet. So that's one of the reasons why population has grown and so forth. It's been stable enough, humans have been able to do pretty well. Prior to that, they were scrambling all the time because things were changing. And as hunter-gatherers, they were constantly on the move. Okay, now let's look at even a briefer window in time, the last 130 years. This is approximately from, in the late 1800s when urbanization was rampant. We had basically a growth in industrialization, and we started basically burning coal and oil and, and so forth. We started utilizing fossil fuels to a great degree. And this is what the carbon dioxide started doing. This line, the black line, is carbon dioxide concentration, and like I say, now it's above 400. And the temperature, the global temperature, is what these little bars are. So the global temperature has continued to go up over that entire period, matching pretty much what carbon dioxide had been doing in the atmosphere. And then here's sea level rise from that same period in 1880. And sea level has been marching on up, and we've measured that lots of different ways. This red is basically where we measure, where NASA measures sea level over the entire oceans from satellites. They basically use radar altimetry from satellites a couple hundred miles up and measure sea level to within millimeters over the entire planet every day. So that's what this red is. So it's continuing to march on up. Okay, well here's the track of carbon emissions during this industrial age. So you can see back in the mid-1800s, almost none. And then we started utilizing coal, then we started utilizing oil, then we started utilizing natural gas. And currently, we're using a lot of those fossil fuels, essentially. And all that carbon emission is going into the atmosphere. Millions of metric tons per year. Okay, well, the reason that's an issue is the carbon dioxide going into the atmosphere along with methane and other greenhouse gases basically put a layer up there that disturbs the balance of radiation on the planet. So the sun's power comes in, some of it gets absorbed, some of it gets radiated back out, and putting this blanket of greenhouse gases in there disturbs this balance. And this is basically the radiative forcing components of this. So these are basically how all of that balances in the atmosphere and trying to distribute basically the energy. Everything above this zero line are things that warm the planet. Everything below that line cool the planet. So there needs to be a balance between these two if it's going to be stable. And you can see there's a whole lot more stuff above the line than there is below the line, even with taking error bars into account. So measuring these things on a planet scale is difficult. So there are some error bars. But you can see carbon dioxide, we have a pretty good handle on what that is. And that's a huge impact. And here's methane. That's a big impact as well. And these things that make the planet more reflective and basically dissipate more energy back to space, those are smaller. So if you add all of these things together and subtract this stuff off, this is what you get. This is on the positive warming side. That's how far out of balance things are. And now you might say, well, you know, you talked about all this climate change that occurred before man had anything to do with it, you know, naturally. Well, that's the green. So if you account for the solar spot cycles and so forth and how much radiation we're getting from the sun, we've been measuring that pretty accurately for the last 100 years. So we know what that's been. And we also have been tracking basically what all the volcanoes have been doing and on and on. So we've accounted for all of that. So this green bar, or the green area, is what our global temperature would have done without man's influence, just natural influence. And you can see it's generally pretty stable. There's fluctuation, but the overall trend of that line over the last 100 years has been pretty stable. And we can account for all that. But this black line is what we've observed has happened, and it's, in the last 50 years, it's gone up significantly. And if you take the natural variability and add to it what the human factors have done, basically the carbon dioxide and so forth and other gases that we've dumped into the atmosphere, and you know, and impacts to the Earth's surface, basically deforestation and urbanization and all these other things, you get basically this purple shaded area. And notice that purple shaded area tracks pretty well, taking into account natural and human factors, to what we've observed. So this is essentially what we're faced with now, is a very sharp increase, and that's not a good trend line. So what are the changes? And we don't need to go through all these, but I wanted you to have a perspective that when we talk about global warming or talk about climate change, it's more than just the atmospheric temperature rising, and it's more than sea level rise. And you also ought to be aware that sea level rise comes from two factors, basically. The one is, as the atmosphere warms, the oceans then warm, and as the ocean water warms, it thermally expands. And so the same amount of water, if it's warmer, will expand and take more volume, so it increases the height. So about half of the sea level rise that we're seeing and expect in the future is from the water just warming up. And the other half is from melting glaciers and ice sheets, which we also see happening. All across the planet, the glaciers are retreating. More of that ice is basically going off of the continents into the ocean, raising the level. And these can be significant factors. Like I mentioned before, and maybe I'll restate this, that 800,000 year window that we had with ice cores that we had a pretty good handle on, sea level fluctuation during that period is about 500 feet. It's been 100 feet higher than today and like 400 feet lower than today. So that's the kind of, you know, variability we're going to see. Now, if you saw water levels rise in the ocean 100 feet, what would that do to civilizations across the planet? You know, I mean, a lot of people live at a whole lot lower elevation than that. The highest elevation in Florida is only like 300 feet. And you think of the central part of Florida, like Orlando, that's less than 100 feet. So anyway, we're going to have big impacts. But also all these other things. As the Arctic ice melts, that's going to have political implications, cultural implications. You know, we think of cultural, we have the Inuit Indians as an example up there that are going to be displaced. Transportation is a huge issue with the Arctic ice melting. We're going to have transportation routes across the Arctic, which is basically going to be a challenge for us, I guess. And then the environmental impacts associated with that. And then, let's just jump down here. Increase in frequency and magnitude of extreme weather events. I think we just saw one this past week, didn't we? You know? And that is well described or well expected with a warming Arctic. When the Arctic warms, it essentially, and the Arctic is warmed significantly, it reduces the polar vortex and allows that cold air to slosh down, as we saw in the last week, you know, down over North America in this case, eastern United States. Last year we saw similar outbreaks essentially in Europe and in Russia. So as we go forward with the Arctic warming, we're going to see more extremes like that in the winter as well as the summer. And we're going to see stronger hurricanes and other types of extreme events and stronger rainstorms, more intense rainstorms and so forth. Other things that we're going to see change is ocean acidification. As we put carbon dioxide into the atmosphere, that carbon dioxide, as it's absorbed by the ocean, forms carbonic acid. So it drives the pH, or the acidity level, in the ocean down, and that starts to dissolve coral reefs and stress the ecosystems in the oceans as well. So we have those impacts that we're already seeing, and we're going to see that magnified as well. Public health effects, heat waves, vector-borne disease. Like in South Florida, we're already seeing a comeback of some of the tropical diseases such as dengue fever and so forth. So we're going to see more and more issues with vector-borne disease with a warming climate as well. Droughts and floods. Just look to the western United States. We've got wildfires and so forth the last few years. Well, that's exactly what's expected because it's going to get drier and drier in the southeast over the next 100 years based on the models. So we're going to expect more and more of that to occur in the western U.S. Ecosystem impacts because of the changes, agricultural impacts, the crops that we grow in certain places aren't going to grow as well with changes in moisture patterns and temperatures and so forth. Water resources impacts in quantity and timing. Well, again, in the West, things are going to dry out. They're already water starved, and they're going to get less water from precipitation going forward. Impacts of transportation, particularly along the coastal area, roads and rail systems and shipping and all that's going to be impacted by sea levels that are increasing. So anyway, and then as the places are less habitable, we're going to see human populations displaced and be migrating. That's going to be a destabilizing activity for us going forward as well. So these are the types of effects that climate change is causing and will cause in the future. Okay, well, let's think about the ethics of some of this. Well, ethical values are generally the balance between good and evil, what's right, what's wrong, what's just, what's unjust, and whether civilizations and cultures are respected or not. The principles generally are pretty simple. Do not cause harm, contribute to the good of others, be nonviolent and just. Now, these are just basic things that we would all buy into, I think. Be tolerant and respect dignity of others. Pretty much the golden rule. Do to others as you want them to do to you. The ethical challenges for us is we want to safeguard both present and future human generations. We want to safeguard non-human life and ecosystems. That's a big responsibility for us because those non-human folks, they're not at the table. You know, the polar bears are not at the table to decide what we should do with climate change, but they're being impacted by it. So the ecosystem and all the wildlife and whatever out there, they deserve the planet that we share. Now, the cost of pollution, we would think, should be borne by the one polluting. Well, that's difficult. When we pollute here with carbon dioxide in the United States, as an example, by our activities, that impacts folks in Bangladesh. And Bangladesh, very dense population, very low altitude, they're essentially, or elevation, they're essentially right there next to sea level. They're impacted, and they're going to be impacted significantly going forward, long before many of us will be impacted. And that's not ethical or fair that we would cause that harm to them and share no responsibility. The other issue is that's a spatial impact. It's difficult to get a handle on. But temporally also, when we put carbon dioxide into the atmosphere, it stays there hundreds and thousands of years. So it's going to continue impacting future generations thousands of years into the future now. All of this 400 and something parts per million we've dumped in there, it's not just affecting people today, it's going to be affecting future generations for thousands of years. So when you look at that fluctuation graph for the last 800,000 years based on ice cores, you could see when carbon dioxide got high, it didn't fall quickly. It fell very slowly. And that's what we're going to see now. It's not going to fall quickly no matter what we do. But we need to basically turn it around so we can do that. Now, we might be able to engineer some things to try to remove some of that carbon from the atmosphere. But that's pretty extreme. That's a huge volume of, of atmosphere to try to do something with. Okay, let's now think about this relative to our UU. Yeah, let's think about this relative to our UU principles. How many of those 7 UU principles are tied up in what we do with climate change? It's not just the last one, this respect for interdependent web of existence. That's the one that probably you think of first. But it looks to me like there's at least 5 of those that have a direct bearing on this issue. Inherent worth and dignity of every person. We got to think about the impact that we're causing to people all over the planet and future generations. Justice and equity and compassion in human relations. So those are big issues, big questions. So how do we go forward with this? Well, essentially, we can try to improve our science and our understanding of how the climate system works. We can understand or try to improve our understanding and prediction of what the impacts are going to be. We can think about how to and try to develop a better understanding of how we can mitigate climate change from happening. And if we can't, we need to figure out how to adapt to what's happening going forward. And this is a global issue. It's not a simple thing. It's the whole globe that needs to be dealt with. Okay, let me just jump to the last one. When we think about what you can do individually, let's think about our carbon footprint. Oops, let me stop this thing. Okay, our carbon footprint is just generally a total set of greenhouse gas emissions we individually cause, and is usually expressed in terms of the equivalent amount of carbon dioxide, either directly or indirectly, each one of us is putting into the atmosphere based on our activities. So this is a typical carbon footprint for the average family in the United States, consisting of 2.5 people with average income, average home size, and so forth. And it's 48.5 tons of carbon dioxide per year. That's how much the average family is dumping into the atmosphere. And if you look at the size of these blocks, you can see they come in how people travel, what their home consists of and how it's operated, basically what they eat, the goods and services that they demand, and so forth. But the big one that jumps out at you is basically how we fuel our cars that we drive. That's a huge impact overall in this blend of everything that we do. So if you ended up basically doubling the fuel economy of your car, that would reduce the size of this bar significantly. Or if you reduced how many miles you drive, it would make a big difference. So maybe people should think about living closer to where they work, reduce their commute, use mass transit, and so forth. And as people are more affluent, they do more air travel. Air travel puts a tremendous amount of carbon into the atmosphere. So as we choose vacations and we're flying around the planet, we're dumping a lot of carbon in the atmosphere. Maybe we ought to vacation closer to home, and maybe ride a bicycle to do it. Electricity is another big one in your home, and how you heat it, if it's natural gas or other things of that nature. One that you might not have thought of is your food sources. Basically, if you're an organic vegan, you have a very small bar here. Basically, meat produces a lot of greenhouse gases, because basically cows put a whole lot of methane into the atmosphere. Dairy also pretty intense. So there's a tremendous amount of impact in how we choose to eat. And then if the meat is basically from cows that are raised in Australia or Argentina or whatever, then you've also got the transportation costs in carbon of getting it back here to eat it. So we ought to be thinking of eating closer, or food sources that are closer to home. Use local farms and so forth. But anyway, now how can you get this sort of information? Well, you can go online. There's lots of different carbon footprint calculators that you can play with. This particular one is at the Nature Conservancy website, and it was actually developed by University of California, Berkeley. And so this is all available, and it goes through and you put in your information in, how you travel, what your home's like, what you eat, what you shop for, and then it generates your footprint. And then it goes through and gives you actions that you can take to try to reduce that. And it's kind of fun to do that. So here we are, you put in how big your household is. The average is 2.5. What's your income, because that'll basically tie to your disposable income and so forth. And then you talk about travel. How many vehicles do you have? What miles per gallon do they get? How many miles per year you drive them? Do you use public transit? How much air travel do you do? And so forth. And your home, what's your electricity bill per year? How many square feet is it? So you can put in all kinds of information, and it generates your specific information. And then at the end, it comes back and says, okay, here's some steps in transportation that you could do to reduce your footprint. And it goes through and gives you a lot of this personal information. I mentioned the importance of adapting, because whatever we do, it's going to continue to happen. It's just, we need to be thinking long term. But in the short term, we need to be adapting to what's happening. One of the best places that I know that's been doing this is New York City. And one of the reasons I know that is because NASA worked with them to provide the information kind of as a model of how we could do this. So NASA provided all the model runs and all the technical analysis, and then New York basically built, all this climate risk information. They projected out basically where sea level should be along their coasts out 100 years, and they managed to that. So their zoning, all their requirements for new development and replacement of infrastructure, all factors all of this in out 100 years. So they're not building based on what used to be done. They're building what needs to be done for at least 100 years out. And that's probably what coastal communities and other communities really ought to be doing across the country, across the world, really. So like I say, you can go on the web and see what New York is doing, but it's really a model of what should be done. And I think that's about it. Here's my little cartoon at the end, if you can't read it. So it's good news. At the current rate of global warming, we should be able to just swim over there and eat him in under 5 years.